Okay, we're going to get a graph of this thing, and we're going to base it not on like a table with x's and y's. That's okay, but we're going to base this instead on knowing how log functions behave in general. We know that they do that swooping upwards thing from the vertical asymptote. We are going to get the domain, the range, the asymptotes, and the end behavior on the way to getting the graph. By the time we get to the graph, it's going to be borderline automatic. Okay, so domain. The domain for a log function of any base is that the argument of the log function, the thing that goes on the inside, has to be more than 0. So if x plus 2 is more than 0, that means x has to be greater than -2. And if x is greater than -2, then that means I'm dealing with this sort of interval from -2 up to infinity. You do have to have parentheses so that you know that the -2 is not included. The range for every log function, unless something really strange happens, is going to be from -infinity to infinity, because this can have an output of anything. When I say something really strange happening, I mean like ln of x, like squared. That couldn't be negative. So this would be a really strange thing that happens. But you know, that's so weird that we're not going to run into that in our class or really like realistically at all. So just don't worry about it. Usually the range is going to be -infinity to infinity unless something really weird happens. The asymptotes. You know that an exponential function has a horizontal asymptote, but a log function is an inverse of that. So the x's and the y's switch places, and that turns horizontal into vertical. So this will not have a horizontal, but it will have a vertical asymptote. X plus 2 means that this is moved left by 2. So where the vertical asymptote used to be at x equals 0, this has moved it left 2. So bump, bump, it moves it to x equals -2. You can also use the simple fact that a log function will have a vertical asymptote where its argument, its inside, equals 0. So it will be at x equals -2. The end behavior, remember, is a little weird for log functions because x can't go to infinity in both directions. It has an endpoint, and it's based on the domain. X can go to infinity just fine, because look, it goes all the way to infinity. But what x can't do is go to -infinity. That's impossible, because it only goes to -2. It doesn't make it all the way to -infinity. So the end behavior here is going to be classified, like usual, as left and right hand, but the left hand end behavior is only going to involve x going to -2. And get even more specific, it's to -2 from the right hand direction, because x doesn't occupy any numbers lower than -2. It's always above -2, and so it can only approach from one side. With this in mind, we can state the end behavior. Limit as x goes to infinity of this function, ln of x plus 2. Well, think about it. Log of a number that gets bigger and bigger and bigger and bigger, there's no limit to this growth. So that's the side where it goes to infinity. And then the limit as x goes to, oops, not +2, goes to -2 from the right-hand side. Here I'm going to ask you to employ your general knowledge of how log functions are shaped. They are generally shaped like this. And what this means is that as x approaches the vertical asymptote, you're going to be diving down. Where this would switch is if the log function were negative itself. If this were y equals -ln x plus 2, but it's not. So you're not flipping the whole thing upside down. So this is going to approach on the left-hand side as x goes to -2, decreasing down to -2. It's going to go to -infinity. Cool, huh? Okay, so now we have enough info to draw a graph. we'll get the vertical asymptote rockin at -2, -1, -2. There's the vertical asymptote. We know that this thing lives on the right-hand side of the vertical asymptote. It never touches the left-hand side. We know that because of the domain. And where is it going to be equal to, where is it going to be equal to 0? This is like the y-intercept for log functions. The x-intercept for log functions is always the easy thing to find. ln of what equals 0? ln of 1 is 0. So ln of x plus 2 equals 0 tells us that x plus 2 equals 1 or x equals -1. So we know that -1 comma 0 is the x-intercept. That means it's right there. Okay? Now use your general knowledge of how a log function is shaped. It's going to start from this point and go up like that. And then from that point, it's going to go down toward the vertical asymptote like that. If this were another more well-behaved base, we would find other points, but ln is such a bad base for the logarithm that we can't really go and find other numbers because, like, you know, you could say log base 2 of 8 is 3, and you could use that to get some other like whole number things. But ln is always based on e, which is such a messy number that it's just not even worth finding other ones. So I think that this is already good enough. And I'm in charge. So I'm the one who gets to say when it's done. And it's done.